Scientists have gathered a lot of evidence and information about the universe. They have used their observations to develop a theory called the Big Bang. The theory states that originally all the matter in the universe was concentrated into a single incredibly tiny point. This began to enlarge rapidly in a hot explosion, and it is still expanding today. This explosion is called the Big Bang, and happened about 13.7 billion years ago. We believe it happened this long ago because that's how old the oldest stars are, and it is believed that the stars started to form almost immediately after the Big Bang. Nobody knows what there was before the Big Bang, and it is possible that there was nothing at all. When the Big Bang occurred, it released a huge amount of energy and the universe we know was born. Time, matter and space all began with the Big Bang. In a fraction of a second, the universe grew from smaller than a single atom to bigger than a galaxy, and it continues to grow today. As the universe expanded and cooled, the energy changed into particles of matter and antimatter, and these two opposite particles largely destroyed each other. More stable particles called protons and neutrons started to form our universe in the first second. Over the next few minutes, the temperature dropped below 1 million degrees Celsius and became cool enough for the protons and neutrons to come together, forming hydrogen and helium nuclei. After 300,000 years, the universe cooled to around 3,000 degrees, and atomic nuclei could finally capture electrons to form atoms. The universe became filled with clouds which were filled with hydrogen and helium gas. These clouds formed nebulas, which soon developed into the first stars. There are several pieces of evidence which point towards the Big Bang creating our universe. The first piece is something we call redshift of light or galaxies. Light travels to Earth from other galaxies, and as this light gets closer to Earth, the distance between Earth and that galaxy increases, which causes the wavelength of that light to get longer. The redshift of distant galaxies means that the universe is expanding, and if we go back far enough in time, everything must have been squashed together into a tiny dot. The rapid eruption from this tiny dot was the Big Bang. The second is cosmic microwave background, which explains how, very early in history, the whole universe was very hot. As it expanded, the heat left behind a glow, which fills an entire universe. The Big Bang theory not only predicts that this glow should exist, but it should be visible as microwaves. This cosmic microwave background has been accurately measured by orbiting detectors, and is a very good evidence that the Big Bang theory is correct. The third piece of evidence is the mixture of elements. This explains that when the universe expanded and cooled down, some of the elements that we see today were created. The Big Bang theory predicts how much of each element should have made in the early universe, and what we see in very distant galaxies and old stars is just right. It is impossible to look in new stars, like the Sun, for this evidence because they contain elements that were created in previous generations of stars. As such, the composition of stars will be very different from the composition of stars that existed 7 billion years ago, shortly after the Big Bang. The fourth and final piece of evidence can be seen by looking back in time. The main alternative to the Big Bang theory is called the steady-state theory. In this theory, the universe does not change very much with time. Because light takes a long time to travel across the universe, when we look at very distant galaxies, we are also looking back on time. From this we can see that galaxies a long time ago were quite different from those today. This shows us that the universe has changed. This fits better with Big Bang theory than the steady-state theory. Life cycle of a star. Stars are masses of gas that glow in the atmosphere, and depending on the size and how hot they are depends on their visibility to the human eye. Stars can range in size from less than 450 times smaller or over 1,000 times greater in size than the Sun. The temperature of the stars is also dependent on the size. Stars can range from 3,000 to greater than 50,000 degrees Celsius. The atmosphere is filled with what most people think is space, but it is thinly spread with gas and dust, which is commonly known as interstellar medium. The gas that is a part of the interstellar medium is mainly made up of hydrogen, and the dust is made up of grains, which cannot be seen with the human eye microscopic. These grains are made up of silicon and carbon. The first stage of the life cycle of a star, the interstellar medium, is combusted into large masses of dust and gas. This stage is called the nebula and is where the birth of the star begins. The second stage is when the nebula starts to heat up. The heat of the nebula can reach temperatures of around 15 million degrees Celsius in the core of the nebula. This reaction of the heat causes the star to glow. The third stage of the life cycle of a star is due to the extreme temperature that occurs in the core of the forming star. This causes a nuclear reaction. This reaction causes hydrogen to be produced, which then flows out of the nebula to create helium. The fourth and final stage of the creation to form a main sequence star occurs when the star becomes active, releasing energy. This energy causes the star to prevent it from contracting even more than it already has. At this stage, the star begins to become apparent in the sky and starts to shine. Although this is the final stage in creating a main sequence star, the life cycle still continues. The fifth stage is when the star remains in this form for an extensive amount of time, usually around 10 billion years. It will continue to stay in main sequence form until all of the hydrogen that has all been drawn out of the nebula and has transformed into helium. The sixth stage is when the helium that has been transformed into a shell that begins to surround the core of the nebula. The seventh stage is when the core is hot enough that the helium that has been created can fuse, and this can cause carbon. This causes the outer layer of the nebula to start to become larger. The temperature starts to decrease and the brightness of the star starts to lessen. This is called the red giant star. The eighth stage of the life cycle of a star occurs when all of the helium that was in the center of the core has no more of the substance to release. The outer layers of the star start to drift off the outside of the core of the star. This is known as a gaseous shell, and it surrounds the core and is known as the planetary nebula. The ninth stage of the cycle is when 80% of the original star or the core of the star is at its last stages of life. At this stage, the star is known as a white dwarf, as this starts to cool down, and this causes the star to not shine as bright as it previously did. When the star has fully cooled down, it will not shine anymore and it is dead, or known as black dwarf. The Milky Way can be seen as a hazy band of white light. The individual naked eye can only grasp the stars in the sky, which all bond together to form the Milky Way. The Milky Way is full of different shadows and depths. The light that you can often envisage, pictured, originates from the accumulation of unresolved stars and other material located in the direction of the galactic plane. The galactic plane is the disc-shaped line, where most of the mass lies. The dark regions within the band are known as the coal sack. The darkest part in the sky and great rift, which is molecule dust clouds. This is where the light from distant stars are blocked by the interstellar dust, simply dust existing in space. Lastly, the area of the sky that is obscured by the Milky Way is known as the zone of avoidance. The Milky Way has a low visible surface brightness, However, its visibility can be affected by background light, light pollution, or light from the moon, making it difficult to see from a suburban location, and more visible in a rural area, when the moon is below the horizon. The Milky Way is the second largest galaxy in the local group. There are more than 54 galaxies nearby. With the stellar disk, the Milky Way is about 100,000 light-years in diameter and approximately 1,000 light-years thick. Estimates of the mass vary depending upon the method measured and date used, coming to a conclusion that the lightest it could possibly be is 5.8 x 1011 solar masses, and the other end of the scale measuring the weight at 8.5 x 1011. Most of the mass in the Milky Way appears to be dark matter. Dark matter is a non-luminous material which is postulated to exist in space. The Milky Way contains between 200 and 400 billion stars and at least 100 billion planets. The number isn't correct because of difficulty measuring dwarf stars which are hard to detect. The space between the stars is a disk of gas and dust. This is called the interstellar medium. The gas layers range from their type, being hot, cold, thick or thin as to where they stand. Going deeper into the Milky Way, we found ourselves discovering the solar system. The solar system is made up of planets that orbit our sun. In addition to our planets, the solar system also consists of moons, comets, asteroids, minor planets, dust and gas. The Sun contains about 98% of all material in the solar system. Scientists believe that the solar system evolved from a giant cloud of dust and gas. They believed that the gas and dust began to collapse under the weight of its own gravity. The Sun was born in a vast cloud of gas and dust around 5 million years ago. At the center, a body of mass was forming. All the matter fell inward, creating a large amount of heat and pressure. As the Sun grew hotter and hotter, eventually when it reached temperature of about 1 million degrees, its core ignited, causing the Sun to begin nuclear fusion. Earth is just another planet. However, it's an oasis of life, where the temperature, weather, atmosphere and many other factors are in place to keep it just right for us to live on. Life was first found about 3.5 million years ago. Earth occasionally interacts with other objects in space, especially the Sun and the Moon. The Moon is Earth's only satellite and is one of the largest natural satellites in the solar system. The Moon is said to have formed 4.5 billion years ago, not long after the creation of Earth. The Moon was formed from the debris left over after a giant impact between Earth and a planet called Theia. The Milky Way consists of a bar-shaped core region, which is surrounded by, as mentioned before, a disk containing dust and stars. The gas, dust and stars are all organized roughly into the logarithmic spiral arm, which is a spiral or curve often found throughout nature. A deeper understanding of the Milky Way structure shows that there are 4 different quadrants. This simply refers to the fact that the Milky Way has been separated into 4 different sectors, each called galactic quadrants. The galactic center is indeed the center of the galaxy. The Milky Way's central core contains a supermassive black hole. It is commonly referred to as Sagittarius A. It contains the mass of about 2.6 million suns. The spiral arms normally contain a higher density of interstellar gas and dust, however also have a greater concentration of star formation compared to the galactic center. There are thought to be 4 different spiral arms that all start at the center of the Milky Way. These arms are arranged in 2 different colors such as cyan, purple, green, and pink. There are also 2 smaller arms or spurs known under the color orange. The galactic disk is surrounded by a spheroidal halo. This consists of old stars and globular clusters, located around the core of the galaxy. The Milky Way and Andromeda Galaxy are a binary system of giant spiral galaxies. These are a part of the Local Group, which contains 54 closely bound galaxies. There are 2 smaller galaxies and a number of dwarf galaxies that orbit the Milky Way. In 2014, researchers reported that most satellite galaxies of the Milky Way all lie in a huge disk. All the satellite galaxies move in the same direction within the disk. The Earth has been around for 4.5 billion years. In the early years, Earth was completely hostile to life. The early atmosphere was toxic, and constant asteroid bombardment turned the landscape into a wide ocean of molten rock. 500 million years after the formation of the Earth, the environment settles down and it became relatively inhabitable. 40 million to 600 million years after the solar system formed, Earth had water in the crust, and was ready for life. Geologists have found rocks that are 4.3 billion years old and include minerals that required abundant water to form. We know that life began 3.5 billion years ago because that is the age of the oldest rocks with fossil evidence of life on Earth. It appears that the earliest forms of life were thermophilic or hyperthermophilic organism, which means they lived in systems composed of hot water. Early in Earth's history, both volcanism and impact cratering were very common processes. Both may have provided the environments needed to transform chemical compounds into living organisms and may have provided a suitable habitat for that life to evolve. So life began on Earth. Bacteria created a form of photosynthesis. Photosynthesizing cyanobacteria evolved. They used water as a reducing agent, producing oxygen as a waste product. The oxygen concentration in the atmosphere slowly rose, acting as a poison for many bacteria and eventually triggering the Great Oxygenation Event. Life on land was most likely developed at this time. Eukaryotic cells appear. Meiosis and sexual reproduction are present in single-celled eukaryotes. It may have increased the rate of evolution. Multicellular organisms begin to evolve, including red algae. The ozone layer forms and we start to see the first fossil evidence for sponges, corals and sea anemones. There starts to become diversification of living things in the ocean, and evidence of life is found on land. Some of the species of plant life and ocean life we see today begin to evolve, including ferns, sharks, crabs, amphibians. Then the Permian-Triassic extinction event took place, eliminating over 90% of marine species. Life on land took 30 million years to recover. Mesozoic era, then comes the dinosaurs. The earliest one, the prosauropod, the first mammals and teleost fishes. The diversity of dinosaurs increases over the Mesozoic era. The first ants, bees, snakes, ticks and turtle fossils are found from this era. Cenozoic era, the Cretaceous Paleogene extinction event eradicates about half of all animal species, including the dinosaurs. Mammals become the dominant species, and the earliest primates appear. Many of our modern type insects, mammals and other species including whales, camels, butterflies, eagles, pigs, cats, giraffes, bears and a huge increase in bird diversity. Mammoths also appear. This era is also the time of the Great American Interchange. The first known human species, the Homo antecessor, appears, followed by Neanderthals. Modern humans appear in Africa, Then around 50,000 years ago they start to colonize other continents including Asia and Europe. Neanderthals then become extinct. The late glacial maximum occurs. The Earth is now in the modern warm period that we live in today. How humans came to be. Today we are classified as Homo sapiens. Our species began to evolve around 200,000 years ago. It is suggested that modern humans evolved from archaic humans in East Africa 55 million years ago. The first primitive primates evolved, followed by the first gorillas 6 million years ago. Then 5.8 million years ago the oldest human ancestors, the Australopithecus, appear and are thought to be able to walk on two legs. 2.5 million years ago the Homo habilis appears with a brain volume of 600 cm3. Stone tools are started to be used. 1.8 million years ago the Homo erectus is found in Asia. It has a brain size of 1000 cm3. Evidence of fire used 1.6 million years ago, including charred wood and stone tools 500,000 years ago. There is the earliest evidence of shelters and wooden huts 230,000 years ago. Neanderthals appear across Europe. Their extinction only 28,000 years ago. 195,000 years ago Homo sapiens appear. The average brain size is 1350 cm3. 150,000 years ago humans may have been capable of speech. 10,000 years ago, evidence of first villages and domestication of dogs. 500 years ago the Stone Age ends and the Bronze Age begins. 5,000 years ago the earliest known writing appears, and from 4,000 to 3,500 years ago the Sumerians of Mesopotamia developed the world's first civilization.
I don't think it wants to go over 6 minutes.